Today we're on page 6 of our chapter 13 notes packet, picking up where we left off yesterday. Up until this point, we've been solving trig equations that contain just a single trig function. Okay. Now we're going to look at an equation where there's more than one trig function. If we look at the example here, we have 2 cosine squared x plus 3 sine x minus 3 equals 0. Well, we've got a cosine x and we have a sine x. This is due to us. So what we need to do is we need to bring in our identities. If there is more than one trig function in the equation, identities are needed to reduce the equation to a single function for solving. Using the Pythagorean identity, when either sine squared theta or cosine squared theta needs to be replaced. It's the first thing we're going to look at. So starting with sine squared theta plus cosine squared theta equals 1. This is a Pythagorean identity back from chapter 9, I believe, that you have to memorize, right? If we want to get sine squared theta by itself, we would simply subtract cosine squared theta from both sides, and then we would have sine squared theta equals 1 minus cosine squared theta. Or what if I go back to our Pythagorean identity here, and suppose we wanted cosine squared theta by itself. So we simply subtract sine squared theta from both sides, and that would lead us to cosine squared theta equals 1 minus sine squared theta. Okay, so now looking at the example, right, where we have a cosine and a sine, we'll take the cosine squared x and replace it with 1 minus sine squared x. Okay? Since cosine squared x would equal 1 minus sine squared x. So we have 2 parentheses 1 minus sine squared x. So we simply replace 1 minus or cosine squared x with 1 minus sine squared x. And then we continue plus 3 sine x minus 3 equals 0. So we substituted cosine squared x with 1 minus sine squared x. Now remove the parentheses. That means distribute the 2, okay, to get rid of the parentheses. So distributing the 2, we get 2 minus 2 sine squared x. Copy the rest down, plus 3 sine x minus 3 equals 0. Okay, and now let's continue to solve. So we want this in standard form. So let's first combine our like terms, the 2 and the negative 3. So keeping this in standard form, negative 2 sine squared x plus 3 sine x. Positive 2, negative 3 is negative 1. Minus 1 equals 0. Okay, now so it's in standard form, but the only thing is we always like our lead coefficient to be positive. So let's just divide everything by negative 1. Okay, so then we'll have positive 2 sine squared x minus 3 sine x plus 1 equals 0. It's the same as just going through and changing the sign of all our terms. Okay, so now the lead coefficient is 2, it's not 1, so I'll go and attempt to factor this. 2 times 1 is 2. Are there factors of 2 that add to negative 3? Yes, negative 2 and negative 1. Okay, but remember, we multiplied by 2, right? So this is where we'll have to divide by 2. So we have 2 sine x minus 2 over times 2 sine x minus 1, all divided by 2. And 2 divides into my first parenthesis. It goes in and leaves us with what sine x minus 1 times 2 sine x minus 1 equals 0. Set each factor equal to 0 and solve. I'm skipping that step. going right to sine x is going to equal positive 1, and here sine x is going to, we're going to add 1 and divide by 2, equals 1/2. Now, sine x equals 1. At this point, you should be familiar with a sine value of 1 occurs at 90 degrees. And sine x equals 1/2. What angle measure has a sine value of 1/2? 30 degrees. Now this positive 1/2 is, sine is positive in quadrants 1 and 2. So the 30 degrees is in quadrant 1, and in quadrant 2, 180 minus 30 is 150. Three values for theta. Next page. Okay, so try the next one on your own. So pause the video. You want to solve for all values of theta, theta greater than or equal to 0, less than 360, round to the nearest degree if necessary. 4 sine squared theta plus 4 cosine theta equals 5. We've got two different trig values here. We have sine, and then we also have cosine. Okay, so sine squared theta is what we will replace. You can't replace cosine theta with anything, but we can replace sine squared theta. From the other page, sine squared theta is equivalent to 1 minus cosine squared theta. So bring down the 4, replace sine squared theta with 1 minus cosine squared theta. Bring down the rest of the equation, plus 4 cosine theta equals 5. Now distribute. I'm going to bring 5 over in the same step. Minus 5 equals 0. Now combine like terms. This is my quadratic term and my linear term. And now the constant, positive 4 and negative 5 is negative 1. Again, we always want to start off with the lead coefficient being positive, so I'll divide everything by negative 1. So we have 4 cosine squared theta minus 4 cosine theta plus 1 equals 0. And I'll always attempt to factor it if it is factorable. If not, then I'll resort to the quadratic formula. 4 times 1 is 4. Factors of 4 that add to negative 4 are negative 2 and negative 2. I'm running out of room, so I'm going to try this a little off to the side here. All right, so I multiplied by 4, I need to divide by 4. 4 cosine theta minus 2, and another 4 cosine theta minus 2. And break the 4 down into 2 times 2, and 2 will go into one parenthesis and the other 2 into the other. So we end up with 2 cosine theta minus 1 times 2 cosine theta minus 1 equals 0. Solving for theta, cosine of theta equals 1/2. This is what we call a double root, right? So if cosine of theta equals 1/2, then make that 60 degrees. Let's see. So second cos, 0.5, yep, 60 degrees. Okay, so theta is equal to, well, our reference angle is 60 degrees. So let's put down quadrant 1 and quadrant 4. Right, that's where our cosine is positive. 60 degrees, and in quadrant 4, that's 360 minus 60 is 300 degrees. There are two values for theta. Now, if there is a trig function and it's a reciprocal, like cosecant, secant, or cotangent in the equation, then you're going to let cosecant theta be equal to 1 over sine, or secant equal to 1 over cosine, or cotangent equal to 1 over tangent. Then clear the denominator by multiplying each term by the denominator. All right, for this example, we have solve for all theta, theta greater than or equal to 0, less than 2 pi. So our answer has to be written in radian measure. 2 cosine theta plus 1 equals secant theta. Okay, so we have this reciprocal trig function here. Let's copy down 2 cosine theta plus 1 and replace secant theta with what it's equivalent to, 1 over cosine theta. Now we are going to clear the denominator by multiplying each term by the denominator. So in other words, we're going to multiply the entire equation, or each term, by cosine theta. All right. So 2 cosine theta times cosine theta would be 2 cosine squared theta. And then positive 1 times cosine theta is positive 1 cosine theta. And 1 over cosine theta times cosine theta, the cosine thetas divide out, that would leave us with 1. Put this in standard form, so subtract 1. So 2 cosine squared theta plus cosine theta minus 1 equals 0. Try factoring. 2 times negative 1 is negative 2. The factors of negative 2 that add to 1 are positive 2 and negative 1. Multiply to be negative 2, add to be positive 1. So we have 2 cosine theta plus 2, 2 cosine theta minus 1, all divided by 2. Right, this is the middle step. And 2 goes into my first parenthesis. So we're left with cosine theta plus 1 times 2 cosine theta minus 1 equals 0. So here's our factorization. Now, setting each equal to 0, skipping that and going right to the values, cosine theta equals negative 1, and cosine theta equals 1/2, adding 1, dividing by 2. Okay, so cosine theta equals negative 1. Again, quadrantal angle. What has a cosine value of negative 1? It's 180 degrees, or pi radians. For cosine theta equals 1/2. All right. That's quadrants 1 and quadrants 4 again. And we have it above. It's the 60 and 300. And let's just convert them to radian measure. That's pi over 3 radians. And 5 pi over 3. So there are 3 values for theta. All right. So again, if you would pause the video here and try the next one on your own, and then we're going to stop after this. Solve for all values of theta, theta greater than or equal to 0, less than 360 degrees. Round to the nearest degree if necessary. Okay, we have tangent theta minus 5 equals 6 cotangent theta, meaning 6 times cotangent theta. Okay, so cotangent theta replaced with 1 over tangent. So that's 6 times 1 over tangent, or simply 6 over tangent theta. Now, we're going to multiply every single term by tangent theta. So we're multiplying the entire equation by tangent theta. So tangent theta times tangent theta is tangent squared theta. Negative 5 times tangent theta is negative 5 tangent theta. And 6 over tangent theta times tangent theta over 1. The tangent thetas divide out, and that's 6. Put it in standard form. Subtract 6. Well, this is nice in that the lead coefficient is 1. Are there factors of negative 6 that add to negative 5? Yes, negative 6 and positive 1. So we have tangent theta minus 6 times tangent theta plus 1 equals 0. So tangent theta equals 6, and tangent theta equals negative 1. Tangent theta equals 6 and negative 1. Okay, we've got to get our reference angles. So we do second tan 6. The nearest degree, that would be 81 degrees. This is a positive value. Tangent is positive in quadrants 1 and 3. So quadrant 1, 81 degrees. Quadrant 3, that would be 180 plus 81, which is 261. And tangent theta equals negative 1, the reference angle. Remember, we're keying in second tan 1. 45 degrees is a reference angle. Tangent is negative in quadrants 2 and 4, and a 45-degree reference angle in quadrant 2. 180 minus 4 would be coterminal with a 135-degree angle. And in quadrant 4, 360 minus 45, 315. And there are our 4 values of theta. And this concludes tonight's video. Thank you.